I'm Tyler Sloan.
I'm Daniel Miller.
And I'm Cody Hyman.
And we are Team Thunderbox. The Thunderbox is a high-power motor amplifier for research applications. The 9-square-inch footprint fits easily into robots and is capable of supplying nearly 10 kilowatts of power peak. That's more than 4 times the power density of other brushless DC motor amplifiers on the market. To boot, it's also about half the cost of the next best brushless DC motor amplifier on the market in that form factor. The Thunderbox engineering requirements are based around 3 main areas. The first being that it can actually drive motors at high power. That being because the Thunderbox is a high-powered motor amplifier. That's why about a third of our engineering requirements are based around the input voltages, which are available on Atrius, the robot which the Thunderbox is meant for, as well as that they are compatible with the motors Atrius uses, and finally that they can actually drive them at high currents. The next main area of Thunderbox engineering requirements is that they have a suitable control interface. That's so that the DRL personnel can control the Thunderbox very dynamically in their applications to not only have high currents, but also have the very specific current that they're looking for in controlling the Thunderbox. That's why the other Thunderbox engineering requirements are very much centered around its compatibility with communicating with DRL hardware. The final section of the system requirements that are connected to the Thunderbox are centered around safety. That's because when you have so much power going through such expensive equipment, you want to be able to quickly shut it off when a fault condition is detected in a safe manner. So again, a good third of our engineering requirements are based wholly around making sure that when a fault condition occurs, Thunderbox shuts down in a safe manner.
The 10 Thunderbox engineering requirements that were evaluated in this course were to be able to have the ability to drive a 50 amp sinusoidal peak current through each phase of the Thunderbox, to have an RS-232 compatible debugging interface for easy debug access, to be compatible with a 24-pole 3-phase brushless DC motor as used on the Dynamic Robotics Laboratory's Atrius robot, to have a programmable over-temperature emergency stop generation that is adjustable between 80 to 150 degrees Celsius to protect in the event of an over-temperature condition, to have a fast sub-10 millisecond response time to an incoming external emergency stop signal, to fit into a small size footprint measuring only 5.75 inches by 7 inches by 3.8 inches, to have a 30 to 55 volt DC input supply voltage range and only one input supply, to be able to have an over and under voltage detection circuit that can respond to an excess or under voltage condition within 10 milliseconds, to have a USB reprogramming interface to reflash firmware onto the Thunderbox, and lastly, to have a hardware SPI interface to allow the Thunderbox to communicate with Dynamic Robotics Laboratory hardware, such as their Medulla processor interface. All of these engineering requirements and more were met during the course of this development cycle. Now, let's go over the Thunderbox systems in a diagram format.